Hey there guys. In the next couple of videos we're going to go back to factoring and we're going to review some factoring methods that we already know and also learn some new ones. So today's video is going to be focused on factoring binomials, so that's two-term polynomials, and review the methods we already know in addition to learning a couple of new ones. So let's first of all start with the first factoring method we learned, and that was factoring out a GCF. So number one, if you have the binomial 12a cubed plus 10a squared, first thing you start with is looking for a GCF. The GCF of 12 and 10 is 2, and you can also factor out an a squared from each of these terms. So you factor that out, and you're left with a 6a plus 5. That's how you factor a binomial. That's the first thing you start with, at least, is looking for a GCF, and that's what we do for number one. Number two, you have a GCF of 7 for 14 and 7. You can factor out an m squared from each term, and you can also factor out an n squared from each term. So if you do that, you're left with 2 m to the 6th n cubed for your first term, and then your second term you're just left with a minus 1. Okay, so always check for a GCF first, and then sometimes that's all you can do for binomials. However, we do have special types of binomials called differences of squares. Anytime you have a perfect square subtracting a perfect square, like a squared minus b squared, that can be factored using a special rule. So we're going to review how to do that. Remember, your perfect squares are the numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, etc. Okay, that list goes on and on and on. So you're responsible for knowing those numbers and recognizing those. Okay, the first 15 or so should come pretty easily. And the rule is, if you have a difference of two squares, like a squared minus b squared, it factors like this. It factors into two binomials. One of them is a minus b, and the other one is a plus b. Okay, so for number 3 here, there's no GCF, but I noticed that 9x squared is a perfect square because 3x times 3x is 9x squared. And 49y squared is a perfect square because 7y times 7y is 49y squared. So I can factor this into my two binomials. Again, 3x times itself gives you the 9x squared. So 3x is the first term in each of these. And 7y times itself gives you the 49y squared. So you have a 3x minus 7y and a 3x plus 7y. And that's how this factors. Number 4, I don't see any perfect squares here, but also I didn't check for a GCF. That's the first thing I need to do. 72 and 2, the greatest common factor is 2. So if I factor out a 2 of each of these, then I get 36c to the 4th minus 1. And now I see that in this binomial that's left over, I have a difference of squares. 36c to the 4th. If I take 6c squared times itself, that gives me 36c to the 4th. So that's going to be my first term in each of these binomials. And then 1 times 1 is 1. So this becomes 6c squared minus 1 times the quantity 6c squared plus 1. And then that 2 has to come down that we factored out. Now, it might be tempting to try to factor this further because you see a 6c squared minus 1. But remember, 6 is not a perfect square, so even though there's a c squared here and a 1 here, this is not a difference of squares because 6 isn't on your perfect squares list. So this right here is your factored answer. Okay, number 5. So again, start with the GCF. I see a 7 that I can factor out of 7 and 28. You can also factor out an m from both terms and an n from both terms. So that's your GCF. You're left over with, in your first term, just m to the 6th, and then your second term would be minus 4n squared. So again, this is a difference of squares left over here in the binomial. Anytime you have a even-powered exponent, that's automatically a perfect square. okay, because you can square m to get m squared. You can square m squared to get m to the fourth. You can square m cubed to get m to the sixth. So all even-powered exponents have a square root, okay? So they're automatically perfect squares. So the square root of m to the sixth would just be m cubed. So m cubed times itself gives you m to the sixth. So that will be the first term in your factored binomials. And then the square root of 4n squared would be 2n. So you have a minus 2n here and a plus 2n here. And then your GCF again, 7mn, just comes down. So always be looking for those differences of squares in your... Okay, number 6, 10w to the fifth minus 10w. I see a GCF of 10w that I can factor out of each of those terms. And so that leaves me with w to the fourth minus 1. W to the fourth minus 1 is a difference of squares. W squared times itself gives you w to the fourth, so that's the first term here and here. And then 1 times 1 will give you 1, so you have a w squared minus 1 times a w squared plus 1. But then notice that w squared minus 1 is also a difference of squares. You can factor w squared minus 1 into two binomials, w minus 1 times w plus 1. So you have to keep going for this part right here. Everything else, w squared plus 1, that can't factor anymore. A sum of squares cannot factor, so that just comes down, and then your GCF comes down as well. So your factored answer is this, 10w times the quantity w minus 1 times the quantity w plus 1 times the quantity w squared plus 1. Okay, so those were the factoring methods that you already knew for factoring binomials. Now we're going to get into some new factoring methods. And the first factoring method is called a sum of cubes, and it's exactly what it sounds like. If you have a perfect cube plus another perfect cube, that can be factored. Let's remind ourselves of what the perfect cubes are. So those are numbers that have cubed roots. So 1 cubed is 1, 1's a perfect cube. 2 cubed is 8, so 8 is a perfect cube. 3 cubed is 27. 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512. And then you could go on and on and on, but you really need to concentrate on memorizing those first 8 and recognizing them as perfect cubes. Okay, and the rule is if we have a sum of cubes, a cubed plus b cubed, it factors into the following. It factors into a binomial times a trinomial. Okay, a binomial times a trinomial. The binomial will just be a plus b, and then the trinomial will be a squared minus ab plus b squared. Okay, a squared minus ab plus b squared. Before we get into these examples, I'm also going to jump down here. We're also going to learn how to factor a difference of cubes. A difference of cubes would be two perfect cubes being subtracted from each other. The rule for factoring a difference of cubes is very similar to the rule for factoring a sum of cubes, except for a difference in the signs. So I'm just going to show you both of these rules at the same time. That way you can see how the signs are related. Everything else stays the same. So it's still a binomial times a trinomial when you have a difference. You still have an a here and a b here. You still have an a squared here, an ab in the middle, and a b squared at the end. The only difference is for a difference of cubes, this sign is a minus sign, this sign is a plus sign, and then this sign here is still a plus sign for a difference of cubes. So I have a little acronym to help you remember the signs for sums and differences of cubes. And that acronym is called SOAP. Okay, S-O-A-P. And that acronym SOAP stands for same, opposite, always positive. Okay, and that's a way for you to help remember your signs. So for a sum of cubes, your first sign is the same. So for a sum, it's a plus sign. Your next sign is the opposite, so a minus sign. And then the last sign is always positive. For a difference of cubes, the first sign is the same, so a minus for a difference of cubes. The next sign is the opposite, so a plus. And then the last sign is always positive. Okay, so we're going to practice using that acronym here as well as the rule as we do these last few examples. So number 7, x cubed plus 27. So you have to look at each term separately and think, what's the cubed root of x cubed and what's the cubed root of 27? And sometimes it helps just to write it out like this. Okay, so what are you cubing to get x cubed and what are you cubing to get 27? Well, you're cubing x to get x cubed, and then you're cubing 3 to get 27. So this binomial is going to factor as follows. Let's first of all start with the signs. If you use your SOAP, this is a sum of cubes, so your first sign will be the same, plus, your next sign will be a minus, opposite, and then your last sign will be always positive. The first two terms are just your x and your 3. X here, 3 here. That's your binomial, x plus 3. In your trinomial, your first term is just going to be your x squared. So this is x squared. Your last term is your 3 squared. So 3 squared is 9. And then the middle term is just your a times b. So in this case, it's your x times 3. X times 3 is 3x. So this becomes x plus 3 times the quantity x squared minus 3x plus 9. When you're factoring, you're always supposed to check your leftover binomials and trinomials to see if they'll factor further. Anytime you're factoring a sum or difference of cubes, this trinomial here will never factor further. So that saves you a little bit of time. If you factor a sum or difference of cubes, the trinomial that results from that will never factor further. So this is definitely your final answer. Okay, let's practice another one. M cubed plus 216 n cubed. So let's think about what are you cubing to get m cubed and what are you cubing to get 216 n cubed. Well, the m is pretty easy. You're cubing m to get m cubed. 216, the cubed root of 216 is 6. So you're cubing a 6n to get 216 n cubed. So this is going to factor as follows. Do your signs first. Use your SOAP. Same, opposite, always positive. You have an m plus 6n that goes in your binomial. If you square m, you get m squared. If you square 6n, you get 36n squared. So that goes as your last term, 36n squared. And then in the middle, m times 6n is just 6mn. So this is how that binomial factors. Okay, number 9. This time you have a GCF that you need to factor out first. 504, the GCF is 4. So we'll write this as 4 times the quantity 125 a cubed plus 1. So now you'll bring that 4 down. That will be in your answer. You're focused on factoring that binomial that's left. So think, what cubed will give you 125a cubed, and what cubed will give you 1? Well, the 1's pretty easy. 1 cubed is itself. So that goes there. 125a cubed, if you cube 5, that will give you the 125. So this is going to be a 5a here. So that means your binomial is going to be 5a plus 1. Let's do those signs. Same, opposite, always positive. So 5a plus 1 for your binomial. Now take your 5a. If you square 5a, you get 25a squared. That goes here. If you square 1, you get a 1 here, and then multiply these two for your middle term. 5a times 1 is just 5a. So this is your final answer, and again, make sure you include that GCF of 4 in your answer as well. Okay, number 10, 24c to the fourth d plus 375c d to the fourth. You have a GCF you can factor out, and that GCF is 3c d. Okay, so make sure you factor that out first, 3cd. You're then left with 8c cubed plus 125d cubed. Okay, so bring your 3cd down, and now we have a sum of cubes left over. So we're going to do a same, opposite, always positive, and let's think about what's going to go in our binomial first. So what are you cubing to get 8c cubed? You're cubing 2c. 2 cubed is 8, c cubed is c cubed. What are you cubing to get 125d cubed? Well, that would be a 5d. So that's your binomial. And then for your trinomial, 2c squared, that will give you 4c squared. 5d, if you square that, you get 25d squared. And then if you multiply those terms together, 2c times 5d, that is 10cd. Okay, we're going to try one more together, and then I'm going to leave you to do the last 3 on your own. So 11 through 14, these are differences of cubes, but you factor them exactly the same as sums of cubes, except for the only difference in those signs. Okay, so for number 11, there's no GCF, so we'll just write our binomial and our trinomial. Your signs, same, opposite, always positive. So these are your signs for number 11. Okay, a minus, a plus, then a plus. You're cubing x to get x cubed. You're cubing 1 to get 1. So your binomial is x minus 1. If you square x, you get x squared. So that goes here. If you square 1, you get 1. That goes there. And 1 times x is just x. So this is how number 11 factors. X minus 1 times the trinomial x squared plus x plus 1. So now I want you to practice with 12, 13, and 14. Check for GCFs first for each of those, and then factor using that rule. And again, be careful with your signs. Okay, it should be a minus here, a plus here, and a plus here for differences of cubes. We'll check those in class the next time. Until I see you then, have a nice day. You're all wonderful people. Take care.